Hello guys, today I wanted to show you what D can achieve, and D can, for example, read SQLite databases, and for that I'm going to show you a test application written in D using the C library, linking to the C library of SQLite. So this is very easy. We open a SQLite database, views test.4. We execute this statement here, which selects one column from the album table, the title column, and then we iterate through this, and while we iterate through it, we make the first character of that part of a checksum. And after that we print out the checksum, res here, and we print out how much time it has taken. Okay? And we compile it with the GDC to make sure that the code will be fast and that we have a nice comparison. So we run this program and it takes 53 microseconds. Maybe it runs a bit faster sometimes, if we are lucky, 52 there. Okay. Now we do the same task using the SQLite database library that I have written, and we open the database here, views test4. We go through each row in the table album. We take the first column as a string, and we use the same formula to compute the checksum, which is the position of the thing times the first character. And after that we print the result of the checksum and the time it has taken. Now we give the build command for that, and we do it with GDC as well. And it takes 28 microseconds. Now maybe we just were lucky and stuff was in the cache. Let's try it a few more times. And there we can see the worst result we get is 33 microseconds. And let's calculate how much faster this is. 53 over 33. And it's roughly 1.6 times faster. No, maybe we were really lucky and we should run it a few more times. And we can see when we get very, very unlucky and the scheduler swaps us out while we're reading the database, we get worse performance, right? We get really bad performance here, but usually we get 25, 32. That's the thing we can get. So 33 is really a quite fair thing. 37 maybe would still be 1.4 times faster, so we would still be quite a bit faster. Well, of course not in very extreme cases, but usually we are faster than the one that used the external library. Now the external library is more stable, but we are going for peak times here. Now let's see how much source we need to do this. Within this folder is the whole library. We need to read this and the application. And it takes us 1,400 lines of code to do this. and I've downloaded the SQLite sources just so we can see how much source code they take, and they of course parse the SQLite queries and have a virtual machine in there that does it. So let's be very generous and just count the header file. So the lines of code is 1300,000, and just the header file is 1.9k. So the whole source we need to do to read SQLite databases in high level D code is 1.4k, and this is less than just the header file for SQLite. And I think this is pretty hardcore. So yeah, I hope that this shed a bit of light on the word use of D. And please leave comments, and you can ask me about sqlite-d anytime. sqlite-d, by the way, is just a reader. It can just read the database format. It doesn't do much more. So SQLite 3 is for you if you want to use SQL stuff and queries. But if you want to build the queries yourself, then you can use D and you will get more performance out of it. So with that, see you next time.